My name is Mark Baker. I know actually on the session this was listed as being Arturo Suarez. He's one of my colleagues. He got pulled away on a important and hopefully lucrative customer opportunity. And I drew the great opportunity. I was going to say short straw, but the great opportunity to come and talk to you. Welcome. Please come and sit down. And I'm talking about benchmarking VNF performance and interoperability using OpenStack. And so just by way of introduction, I'm the OpenStack product manager at Canonical. Sit in what we grandly call the product strategy team, but really is kind of product management, product marketing. And have spent I've been doing this role for a few years, and have a lot of that time spent working with carriers and indeed VNF vendors. So have hopefully some insight and value I can bring. So apologize in advance. There's kind of three who we are, what we do, why we're great marketing type slides. So including the obligatory NASCAR slide. So OpenStack with Ubuntu. Is anybody using OpenStack today? Good. Anyone doing it with Ubuntu today? Okay, good. Good. These people represent opportunity, which is good. So OpenStack Foundation Survey, Ubuntu is very popular as a platform for running OpenStack, right? And sometimes that's our OpenStack distribution, Ubuntu OpenStack. Sometimes it's somebody else's OpenStack distribution. Sometimes it's a handcrafted, home-built, homebrew OpenStack distribution. But Ubuntu is very popular. Some of that is by virtue of the fact that we were one of the founding members of OpenStack in early and had that first mover advantage. Some of that is because we've done, hopefully, some of the right things, right? So people like using our technology. You can give me that feedback one way or another yourselves. This data, by the way, is your choice of operating system for running your OpenStack. And this is specifically large clouds. Large clouds meaning over 1,000 users, which I think is kind of stretching the definition of a large cloud, really. But nonetheless, it's the Foundation Survey data itself. This is interesting, and it was very interesting in the last session. My esteemed colleague from Red Hat was saying one of the advantages you have as a Linux distribution that also builds an OpenStack distribution is that you tightly integrate those two. And the Foundation Survey data backs that up. Right? So what packages are people using for their OpenStack? Where do they get them from? Most people? Oh, no, I'm good. I'm fine. Thank you. Most people are using using unmodified packages from an operating system vendor. Right? Plain and simply because of the integration and engineering that goes into ensuring all of that virtualization stack, all of the OpenStack components, the networking layers, etc., that tight integration between the OpenStack pieces and the OS is hard and very important. So you need to have a good insight on both. Nothing new there, I guess, for most of you. Obligatory NASCAR slide. So these are all people that are doing OpenStack in some way, shape, or form and paying Canonical money to do so. It is sadly, it's a very small percentage of the people that actually use our technology. Right? We are a freely available technology. Download it, use it for in quotes for free, assuming your time is worth nothing, but in quotes, use it for free. And but if you see value in having a commercial relationship with us, either for support, service, maintenance, some value-added tools, then pay us some money. And all of these people do to some degree. Some of them millions of dollars a year, some of them a lot less than that, right? But there's some obviously some significant names, and that's, as I say, that's just a handful of them. So. The astute amongst you will notice that OpenStack distributors often show the same logos, right? Why? Because big telcos, I'll pick on our friends at AT&T, for example, are not really one company. So they have multiple, I shouldn't pick on AT&T actually. But big telcos often have multiple subsidiaries, multiple competing OpenStack implementations, and therefore we all list the same people. So this is not some kind of a scam I'm trying to throw at you. So performance matters. Right? Why does performance matter? If we're looking at a public cloud, yes, you want things to run fast, but it's not your primary reason for using that cloud. Maybe fast provisioning, maybe fast access to storage, maybe the ability to create a new network quickly. But the actual throughput of the VM, the actual throughput of the application, is not necessarily something that is your primary metric, your primary piece. But that's different in the telco world, right? And I'm very happy for real telco people to contradict me here. But performance matters when you're moving from a specialist box, right? A specialist box that is serving some network function that's been specifically designed to do that. Maybe have multiple network functions chained together within it, but it's been specifically designed, optimized by a company that specializes in doing that. It could be Ericsson, it could be Alcatel-Lucent or Nokia or whatever, Huawei, ZTE, all of those kind of people, Cisco and others. So it could be those. Those boxes are extremely good at what they do. Extremely good at what they do. And have years of development optimizing them for performance, all of those things. If you move, as one of the goals of moving into this virtualized infrastructure is, I can just go and pick my hardware from HP or Dell or Quanta or Supermicro or whoever it is, common off-the-shelf hardware, right? It's a very different. It hasn't been optimized for the very particular workloads that telcos run. But network latency, network performance are extremely important. One of the drivers on this, if I get the slide to change, there we go, is disaggregation, right? As we're moving from a very specialized box designed to serve very few functions extremely well into this common environment, it brings with it a lot of complexity. So we move from one specialist environment where typically the hardware and application are engineered together to very particular metrics, to an environment where we have potentially in a single telco very many different hardware providers, right? Depending on the state of the project, I will go and buy the best value hardware I can possibly get based upon my volume, my requirements. And then different types. We may be using VMware as a hypervisor, maybe using OpenStack with KVM. We may be using LXD as a container hypervisor, which I won't go into detail now, but happy to offline if people wish. And then, of course, many different VNF vendors running on top, many of whom are relatively new in this environment, right? They've just started virtualizing their network functions. And this was mentioned by Marco in the last session here in this room, was that it boils down to really the economics of this. We have some I can't give you the name of the customer, but a very real example where they costed out, moving from specialist NEP into this more disaggregated environment, and costed all of that out. And then in some of their testing with those virtualized network functions, found that they were getting about 25, 30% less throughput than they had modeled it on, right? Therefore, to get the throughput that they wanted, they required 25 to 30% more servers, right? That moves your economics significantly. So having a very clear indication of what performance you're going to get from a VNF on a given platform using a virtualized network stack, virtualized environment, is extremely important. Not only to the carriers that need to do this, but also the VNF vendors, right? What kind of throughput am I going to be getting? Can I offer to the carriers? How is that going to compare to my competitors? And therefore, how am I going to differentiate? Is this all making sense so far? Good. So I should have accepted the guy when he offered me the clicker. Come on. Oh, I need to go and do this at the top. There we go. Let's try that again. All right, so I'm using the wonderful Ubuntu desktop here, by the way. Feel free to try it. So to try and address this, we announced actually the beginning of the year, just before Mobile World Congress, something grandly called VPIL, right? And this is the VNF Performance and Interoperability Lab, right? And this was largely in response to one of our big customers, but several of them saying, okay, what is the performance? What throughput can we expect, right? You can talk all you like about KVM optimization and technologies like DPDK and SRIV and all those things that are kind of still relatively new, but give me the data, right? What are the packets per second I can process? What's the latency that I'm looking at, right? If I start chaining these functions together and they're different VM images, right, what's the performance I can expect? And our honest answer was we don't know. So we better set up something to find out. So we announced this at Mobile World Congress with several partners involved. And this is really the basis of the rest of the talk, is what is it and what are we finding out so far? So the VNF Performance Interop Lab, or VPIL, is really building on these kind of three basic principles. It's about getting these VNFs in a form where we can start to run CI/CD processes in. i.e., we can, combined with a lot of things that you probably use already, Jenkins and all those kind of good things, be able to have multiple iterations. Let's fire this up in a particular configuration, run a set of tests on it, collect the data, shut it down, see how it runs. See what happened. And that automation is really the NFVI, in our case, OpenStack. Let's build an OpenStack in a particular config. Let's deploy that VNF into it. Let's automate that. We use a tool called Juju, and I'll talk a little bit around that as we go on. And then engineering the support services with the VNF vendor, right? So we'll get a score or a benchmark out of that. It may be good, it may be bad, but either way, we'll then work with the VNF vendor to say, okay, what is it that we would change in your VNF or perhaps in the config to be able to optimize that, right? To improve those numbers. Step one. Step two is, we're doing this performance testing, right? And performance testing would be great to actually get OpenStack view on this because they have a very particular view on it. But performance testing is having a testing framework for any VNF or application in the cloud. Right? And that's tough with lots of VNFs do lots of different things. Right? And I'll come on to talk about a bit how we try to address that. Good news is that Etsy and OpenFV have functional and performance use cases. Right? Brian, if you help me out with the name. I can't remember what's the name of the performance testing suite in OpenFV.
Yardstick.
That's the one. Thank you. I should have put that on. So Yardstick is a testing framework, performance testing framework that's part of OpenFV, and is something that we are looking at. I haven't built this into VPIL yet, but it's something that actually one of my colleagues, Brian as well, is a chap called Narinder Gupta, is busy trying to see how we build that in. And we use something called the Canonical Automated Benchmark Suite. Right? And this is a tool that actually we had in-house. We've had in-house for several years, and we have used. Ubuntu is very popular in public cloud, across Amazon, Azure, whatever. And we use that, the automated benchmarking suite, to benchmark the performance of some standard applications on each of those clouds. And we do that daily, right? And to see the variances in performance, different clouds and variations, if there's any image optimization we need to do in those clouds, or just for plain interest to see how they run. So we already had that, something that is, again, part of VPIL. And then finally, interoperability. So being able to test a particular VNF on OpenStack, does it work? Is it performing? As we start to chain those VNFs, are they performing well, right? One of the pieces that I just said about if we get one set of data, what tuning of the base environment, the NFVI and the operating system, could we do to improve that data? We have to be very careful of, right? Because we don't want to have multiple snowflakes, to use that analogy that was used in the last session, multiple snowflakes or multiple OpenStack implementations that are tuned to a very particular VNF, right? Because then end users or the carriers themselves are going to have very many different implementations of their cloud, which is not what they want. So yes, that's kind of VPIL in a nutshell. We see a lot of operators very interested in it. So those operators, we're not engaged with all of these yet. We certainly had conversations with many of them. But a lot of the network operators are very interested in understanding how these VNF and NFVI vendors perform, right? What's the data? You remember BT, for example, very publicly said, we've tested OpenStack and think it sucks, right? It wasn't, they didn't use those words, but that was kind of it, right? And so BT is a UK company. You may tell from my accent, I'm based in the UK. And so we keep knocking on their door. In fact, I live in a place called Ipswich, which is where BT have their big research station. I know many people that work in BT, and so constantly knock on their door saying, hey, it's getting better. You might want to look at it again, right? And this is one of the things that's kind of interesting for them, right? Okay, well, show me the data, right? Likewise, the VNF vendors, right, the NFVI vendors, as they are getting asked by these guys, how does it perform? Carriers, well, let's go pick anyone from Huawei here? No? Good, I'll pick on Huawei. Carrier will go to Huawei and say, how does your VNF perform? And Huawei say, it performs great, absolutely great. It's the best performing VNF there is. Well, here's the data after we have tested it on Huawei hardware in a Huawei lab, right? Which is not the same, of course, as running in a real network. And so carriers see VPIL as being a notionally independent or neutral, right? If it's biased, at least it's biased towards the NFVI. So we can act as that independent source. And likewise, as VNF vendors as a carrier will chain VNFs together, they want to get an understanding of, okay, if I've got an IMS from Huawei and an EPC from whoever, Genband or whatever, I'm probably picking the very bad examples. Do they play nicely together? But two, who's going to test that, right? Because I can pretty much guarantee that Cisco isn't going to send their VNFs to Huawei for benchmarking and testing, or vice versa, even though they probably all have them, right? So again, we can are starting to act as that neutral third party. What do we have today? Well, in our data center, or one of our data centers actually in Boston, I think it is, we have a pretty simple setup today. So it's 14 HPE DL3 360s. They're running OpenStack. That's running in two OpenStack regions. One of those regions is running KVM as a hypervisor. The other region is running LexD, which is our container hypervisor. Hello.
Hi, so these HP servers, they're using Intel-based technology?
Yes. Are you from Intel? Okay. No, that's quite right. Yes. So they are. Well, actually, the honest answer is I assume so, right? I don't know, but I assume they're using some Intel. Yeah, I mean they're. Yeah. That's their AMD 64 architecture, should we say? So anyway, yes. So Intel-based chipsets. So we got them based into two regions. LexD is a container hypervisor that's used to run machine containers, Linux containers. Can also run Docker containers, but that's not its primary purpose, and we don't really position it in that way. But what that does allow us to do is via some tweaks to the scheduler or config on the scheduler. It's not actually any code on the scheduler. The Nova scheduler allows us to be able to schedule an application to run in a container where it has the entire machine, and it can guarantee that it's the only container running on that machine. So it gives us bare metal-like implementation. I know you can do bare metal with Ironic, but doing it through LexD as a hypervisor that tied into Nova gives us a few benefits, right? And it means that we don't have to implement Ironic in VPIL, which is good for us. So that's what we have today. In the middle here, you see we have the VPIL Test Framework. And this is basically the pieces that run all of the testing, automates all of the testing, and specifies how it works. As we kind of drill down a little into that, where we are today is working with a number of these traffic and load generators, right? So some VNFs have means of being able to test themselves. Others, you need a load generator to exercise it. I'm certainly not the expert in this, so once we scratch through my thin veneer of VNF technology, knowledge, I should say, I may come a crop or any questions that you have. But these load generators will place load upon a VNF, right? So if it's an IMS or an EPC, it will place load upon that and start to simulate, multiple users, multiple connections, whatever it may be. And actually, those we're kind of furthest ahead with Ixia and DataArt, Rebecca. There's a number of others in that space, Spirient and others. These are hopefully well-recognized names in the telco world that have these appliances that they build to enable carriers to test their own environments, right? So it makes sense for us to work with those. Initially, there's also Yardstick from OPNFV that we're working with. But we'll use some kind of we're using load generators, whether it's from these guys or Yardstick, to start to push the VNF. From that VNF, we will then collect data. Most VNFs, I won't say all VNFs, but most VNFs have log logging that they output, basically showing what they are doing at that point. And we collect that, push it into a test, into the data store, which is basically some Cassandra on the back end. We'll then go and collect basically data from all of the pieces in the stack. So in the guest VM, obviously we prefer if it's an Ubuntu VM because it'd be kind of home turf for us. But we're going to collect data from that VM, right? So just from the syslog and from all the various different pieces, stick that into the test data store. From OpenStack itself, this piece was still kind of working on, well, all of it was still working on, to be fair, but this piece, in terms of getting the right information out from the OpenStack and FVI, from Watcher and Canonical and the telemetry setup that we have there, the host operating system that's running Nova and Neutron and those components, so we see that in terms of those metrics and those logs, again, that's Ubuntu and home turf for us, so we can know where to go and pull those pieces out. And then I haven't got this far yet, but from a hardware layer. So HP, pointing at you, you're not HP, but HP with its great hardware, I'm sure has means of being able to extract performance data at a very low level within that, so we can understand what's going on in the system. All of that we're collating into our test data store, and from that then we're generating a dashboard of results that people can go and see. Right now, the one piece I should have put on there was the Canonical Automated Benchmarking Suite, CABS, because that's some of what I will show you as a means of being able to generate, load, or run a benchmark too. I really should have changed my screen before this. There we go. So, have I got it right? Yes. So what I wanted to show you here is actually the first iteration of vPIL. If I step back a bit, one of the things that we wanted to do with this was, originally when we set it up, was to have this environment and that vPIL dashboard, the results, the output of the VNF testing, to publish publicly on a web page. Right? So we would say, VNF vendor A, we ran this test, here's the output. VNF vendor B ran this test, here's the output. We chained A and B together, here's the output. Right? It turns out VNF vendors aren't so keen for us to do that. Probably for good reason, right? Competitive. The guys that are the fastest, number one, very happy. Everybody else, not so happy. So the example that I'm giving here is not as exciting, I'm afraid, as a VNF today. This is an application called MongoDB, which is an object-oriented or object store, right? It's a database. But the principle is exactly the same. I can do whatever I like with MongoDB, hopefully, and no one's going to fire me or come after me. So, but the principle is exactly the same. So I have right now just two scenarios on this, MongoDB performance using LXD. That's hitting the OpenStack region that has LXD as the hypervisor, and one, of course, with KVM that's hitting the region that has KVM specified as its hypervisor. So it allows us to be able to see what's the performance on Mongo with these two different hypervisors. What are we actually doing on here? So if I go and click into here, you'll see that there's a number of different runs that we've been doing on this particular one, on the LXD, and go and drill down a little more. It's running what's a fairly standard MongoDB benchmark, right? This is why it's very easy. I could just show Cassandra or Hadoop, for example, with Terasort. These are very well-established benchmarks, and I don't have to hook up Ixia or validate any confidentiality agreements we have in place with VNF vendors. But so it's running in terms of a standardized MongoDB performance benchmark. We're actually initiating that through the Canonical Automated Benchmark Suite, and it's doing something called, it's calling an action that's defined on the charm. The charm is a bit that we use in Juju to model this system, and basically says to Juju, run this performance benchmark on Mongo on this region. This is the environment. We have the vPIL collector, which is collecting the information, and some of the results on this particular run. Right? If I go and select all of them, so this is all of the runs, you'll see LXD KVM, all of the different runs that I said it, when did I kick it off? It was about late last night when I got in. So you'll see a number of number of these runs that we've been having over the last, a little while, day or so. And I will go and graph those, for example, or generate a report. Cross my fingers. And we'll see, again, just pictorially that data. Right? So we're doing multiple iterations of this. And you'll see that, thankfully, all of them completed. None of those failed. So we know that we've got a certain amount of interop here that Mongo is at least working in this environment. The parameters that we specified during that run, and then a whole ton of metrics. So some of these metrics are the operations per second. Some of these are coming from the underlying operating system. Some of them coming from Mongo. Some of them, you'll see, are coming from average system loads, clearly a operating system parameter, the network interface traffic that we're seeing on different interfaces, right? And so, and this is a relatively simple example with MongoDB. But it gives you a very kind of clear example of, okay, how do we start to, if we're doing it with a VNF, providing we've got the benchmark, the performance test determined. As I say, that's either something that the VNF has itself, something that we write with the VNF vendor, or we would use one of those load generators, one of those industry-recognized benchmarks, to be able to run that. And so a fair amount of information there, and you say we can go and see. I need to generate the report again. I should have saved that. But and of course, if we were doing multiple different VNFs, multiple different environments, we'd see all of that here. So we'd specify the runs. We're going to set a new one, but okay, I want to run these at different times, different increments. Yes, sorry, you had a question? So right now, we're not publishing. So yes, there is, but not in this right now. So we announced this back in February, I think it was. And we've been getting the framework in place and trying to get VNF vendors on board and those things. We are pulling information out of Ceilometer, but we're not publishing it in the dashboard right now. Who uses Ceilometer in here? No, Ceilometer, which is the it's the metering measurement piece of OpenStack. So that's a very common response. You ask that question, and one person will put their hand up, right? Even in the operators meeting, that's very, very common. So Ceilometer is not without its challenges, and so we are. So yes, we are working with Ceilometer. No, we're not quite there yet. How are we doing for time? We're good. We're good. So the VPL model really designed for, say, network operators. This we've set up as a service. So we have telcos that are subscribed to it. So when we run these VNF tests, we will pass the data to them. So say there's a few hurdles that we're jumping through with VNF vendors that want to have input into that. But also we've seen a great deal of interest in implementing this on a particular carrier site. Okay, so they can see the data as a kind of a common thing. It's like miles per gallon or whatever the benchmark. But then they want to try it in their environment and see how does it perform in my particular config. With my set of hardware, my network environment, all the different firewalls and things that I have in place, how does that run? Or to try it with their hypervisor of choice. And so we've got a number of engagements that we're running in exactly that way with those today. The VNF application providers on hardware manufacturers. This is probably where a lot of the hard work with our team is being done today. And that's, sorry, referring back to the previous session if you weren't here, but in the previous session we're saying that some of the hard work with NFV is getting the VNF vendors to virtualize their applications in a sane way, right? So it's not just wrap it in a VM and hand it over. It's how are they architecting it in a more cloud-native way? Are they actually being able to take advantage of a lot of the technologies that we in the community are busy working on, DPTK and SRIOV and those moving targets constantly? Are they able to test and validate it against the different SDNs that may be also implemented in conjunction with an OpenStack implementation, right? So there's a lot of coordination here that we have to do. And a lot of these VNF application vendors are used to owning the whole stack, and used to dictating all of the terms, right? And so it's kind of tough for us as little Canonical, as an OpenStack and Linux company, to say, your VNF vendor, you're doing it wrong, right? Here's a different or a better way that you might want to consider. And so those are interesting discussions that our alliances team are involved with right now. And then the network test providers, the labs. So the people like DataArt, people like Ixia, Spirient, Rebecca, and others, how do they see this, right? Where do they fit in? Because we want them to be involved. They're industry recognized. They see the value of having a neutral third party. But they also are used to selling their things as appliances, typically into network carriers, network providers, for large amounts of money. So they don't want to see that erode in any way. So that's kind of covered. We've been covering performance thus far. The other piece is Interop. And now, back in 2014, I think it was, we started, no, in fact, it was earlier than that, 2013, we started building something we refer to as OIL. It stands for the OpenStack Interoperability Lab. Right? And that, again, that's a lab that's 100-plus servers that we built. It's a mixture of environments. So actually, that contains non-Intel, contains some Power, and contains Power 8, contains some ARM chipsets, contains lots of different stuff actually in there. But that was as the number of OpenStack projects exploded, was how do we track the interoperability of those, right? How can we ensure that telemetry works with this version of Cinder, that works with this particular SDN, that works with this particular storage implementation, right? And so we started to build OIL, and that was all about these different permutations and combinations. So let's build Nova with KVM. Let's have use a storage Cinder driver, but to power. Use Ceph as a backend on that. Let's have Neutron Network integrated with a Cisco Nexus, for example. See how those work, right? And so we'll find the combinations that work, those that work well, and those that don't work at all, by having this environment that allows us to be able to test that. You see, and then we kind of expand that using different combinations. And we've got, I think it may even be the next slide. There we go. Again, just a handful of partners that we have involved in this interoperability lab. We don't publish the results publicly because some of it's very sensitive, so that we can say, for example, in certain configurations, we see storage vendor A is actually going to be better than storage vendor B. That's very sensitive information. So, or network vendor A and B, whatever. Very sensitive information, so we don't publish that. We do, of course, give that data back to the vendors that we engage with. The nice thing is that we spent 2 + 3 years building all of this environment, generating reports, implementing the framework, and we've done that in exactly the same way, or doing that in exactly the same way with VPIL. We've already got a lot of the primitives in place to be able to manage, okay, let's choose these different vendors, build that as a package, roll it out, test it. With this today, with OIL, it's using, it's built on using the Tempest framework. If you know Tempest in OpenStack, it's testing all of the different API implementations. And we spin up a number of different VMs, Ubuntu, CentOS, Windows, and other things in there too. Try and run some basic workloads, see how they go. And so we've got all of that we built for interoperability for OIL that we're doing with VPIL. Now it's a little more complex, of course, because we are running VNFs, right? So we can't just stand up WordPress and Ubuntu and say, job done. We actually need to stand up a VNF, generate some load on it, see what the performance is like, etc. So it's a bit more complicated, a little more complex, but we have a lot of those pieces in place. This probably covered most of this. So a number of different components, obviously Ubuntu underlying our operating system, different partner technologies. So it could be Scale.io, for example, as a backend storage instead of straight Cinder. We use our own, of course, tooling, Juju Maz, Landscape. These are not Ubuntu specific. There's, Juju and Maz support things like RHEL and CentOS and Windows and other things too. but certainly for this implementation. Then we do the integration. So we have the VPIL test infrastructure, that performance testing, running the performance benchmarks. We did run as I just said, the Tempest Test Framework. In the process of implementing the yardstick, the OPNFV tests, as part of that. And then some of the partners that we work with, so I don't know if Scale.io is a good example, but Contrail, Juniper Contrail, for example, done a lot of work on how they support Juniper Contrail in conjunction with Juju. That allows us to be able to test that. We plug that into the environment and see how it runs. All of those come together basically in this testing, and then we generate those reports. There's the next 3 slides that show different implementations that we've been working on for VEPC. The good thing is most of the names on here, so Metaswitch, so I was talking offline with other people, but you've got Expito, Eurocom, Affirmed Networks. These are VNF vendors that we are working with that are, as we say, charming. That means enabling with Juju, the tooling that we have with this, such that we can then deploy that VNF, actually specifically here in OpenStack, because that's what we care about in this implementation. But our relationship actually spans much beyond that. So it's deploying onto bare metal, into a container environment, or even into a public cloud. To give an example, the Metaswitch IMS, what was known as Project Clearwater previously, we most commonly demo that on AWS. But we take the exact same bundle, as we call it, that we use for AWS, and drop that into OpenStack, and it works in exactly the same way. We're just in the process of testing it on multiple different OpenStacks implementations, such that we can claim a degree of interoperability, which is one of the initiatives running in the OpenStack Foundation right now. The same for vMedia processing. Very interesting, again, from the last session where a gentleman from AT&T, Brian from AT&T, was saying actually now generating the most traffic on their network is video. Right? And we were involved in a project with a big media, I don't know if they're a media or a telco company, I can't name them, but it seems that those two are synonymous anyway now. So that was doing media transcoding and then streaming through. And so obviously CDN plays a big part of that, some of the transcoding, the optimization and encryption of that. So again, that, you can see the VNF vendor there, Vantrix, engaged with to do some of that testing and optimization. And what's the last one? Oh, the VCP. So again, so 6Wind I know as the provider edge and some of their network acceleration technologies. We're working with them, for example. So in the VPIL environment, we just have it native. How does it run? If we add in the 6Wind network acceleration, what differences do we see in the results? Right? Hopefully allows a carrier to very quickly understand, okay, what's the ROI on the 6Wind implementation? Is that going to be beneficial to me or not?
What's UTM1?
I have no idea, I'll be honest. I don't know. I mean, this is, yeah, I don't know. I mean, this firewall, sorry, what was the answer there?
Unified Threat Management.
Thank you. Yes, I was going to hazard a guess, but there's really no point doing that. So the network operators. We've certainly had a lot of pull from network operators. Some of the customers we're public with, Tele2, for example, Deutsche Telekom, have shown great interest in this, right? How do we spin this up? Both, let's get the data from running in our labs, but also how do we then implement it in their networks? And we're doing that with those. But they want to say, the carriers want to be able to pull from a catalog in the same way that you do on your phone. Here's the App Store. I want to be able to pull from a catalog of different VNF vendors, understand those that work together, and what's going to be the expected performance. Because all of that will then feed into their cost model, right? The independent interoperability, that Huawei, Cisco competition, is very real, right? So again, if we've even been approached by a vendor that says we would like you to operate a lab specifically for them. We want to operate it, They want us to operate it, but specifically for them, and test their competitor VNFs, right? I don't know whether we're going to do that or not. That's a commercial decision. But again, because of that sort of neutral third party position. Our value to the VNF vendors is that data helps them sell, right? Yes, it needs to be good data, of course, but data does help them sell. If we can go say to that, whether it's Affirmed or Metaswitch, say to them, okay, we can, with a carrier, we can show not only does your VNF run in an OpenStack environment, we can show that the data around that, the performance that they can expect in different configurations, how it compares to the competitors, and they can see it very, very quickly. If I was more ambitious today, I would have spun up a VNF in a cloud environment to show you how we could do it. That, depending on the VNF, will take somewhere between 15 minutes to an hour. Right? Yes?
One is, who actually does testing? Partners or yourself? Or both?
Both is the answer. So right now, it's us. So we're doing that in our lab. The partners, the carrier, so carriers want to, say, implement this testing on their own sites, and they want to execute the testing, sometimes with different load generator or a different testing framework. That's actually essentially a variation on this that's implemented as a bespoke project for that particular carrier because it's very specific to their environment. The VNF vendors obviously have strong opinions on how we should be testing their products. So it's good to take that input, but we also want to ensure that the test is level and fair, right? So.
But in terms of the VNF knowledge,
Yeah, we've hired the people that created some of these slides know their stuff, right? So clearly better than I do. But we can't be an expert in every VNF, so we have different models for different aspects of this. That's what I'll say. But we give our software away, so we have to make money somehow, right? To come to these fancy events. So yes, there's definitely a commercial model, and that involves money coming to us at some point, either from a carrier or a VNF vendor, or ideally both. Yes?
is there a non-commercial aspect to it? Like if somebody wanted to try it?
So, I mean, Yardstick, you probably know if you're involved in OPNFV in any way, shape, or form. You can go and grab that. OPNFV has a very comprehensive testing framework. The Canonical automated benchmarking suites, all open source, you can go grab that. Juju's all open source. All the charms for the VNFs are all open source. So you could absolutely build this yourself. It's a question of your priorities, time and money. Right?
So, I guess you take your questions, right?
Yeah, sure. We're kind of getting to the wrap-up anyway, I think. So, yeah, I've just kind of, the automation using Juju, we see, again, how we can chain these together so that we can have transport layer, the network service layers, application layers together. So this is actually is it a screenshot? Yes, it is a screenshot of the Juju canvas that we use to create these models as we start to chain our pieces together and run some tests on it. I'll be honest with you, we're not running tests against big complex chain services today. We have to crawl, walk, run. We're certainly not running quite yet. But as we chain these services together, this is actually Juju that's delivering that. It's a common modeling system. Juju's part of OSM, Open Source Mano. I get it wrong. Yes. It's part of OPNFV as well, so it kind of ticks some of the boxes. One of the reasons it ticks those boxes is actually as a generic modeling system, it allows us to be able to take applications, whether they're VNFs or even things like IBM WebSphere, MySQL, or SharePoint, and deploy those across into multiple environments. So whilst the focus of this talk has been OpenStack, we see quite a bit of interest in people saying, okay, well, how do these things just run, in public cloud, on-premise cloud, just in straight containers, right? If I take out those layers. Okay, and I think, there we go. Yes, sorry, Brian, your question.
So, okay, so yeah, in OPNFV we have a performance benchmarking project. Obviously, we're also spinning up let's say a trust marker certification program, whatever you want to call it. You know, performance is going to be one of the aspects of that. So that VNF vendors will be able to, you know, say this has been tested and certified, you know, with these qualities, this level of conformance, this level of performance, right? One of the key things about that is as people bring their VNFs to different test houses, right, to get that certification, is knowing the context that that test was done on.
Right.
So one of the things we're developing is a deep introspection capability about the actual hardware and the virtual and physical hardware,
Right.
software environment in which the test was run. So do you today publish that hardware environment, at least, that these things are, that these tests are run on?
So, I mean, okay, sure. So I've given you as much information as we've ever published today publicly. The architecture, absolutely we can publish. The hardware involved, the setup, the network switches, we can publish that. We're still involved in those discussions as to, with the VNF vendors, what we can publish about test results, right?
Well,
yeah,
but the test environment is of course, publishing that as saying this was our baseline for hardware configuration, virtual software configuration, etc.
Yep, yeah. That's none of that's secret source. That's fine. We happily share that. Great. We're out of time on questions.
Thank you.
Thank you.